This video is all about the equation of a circle. You will have seen this in its very simple form at GCSE, where the centre of the circle was always on the origin. We're going to look at what happens when the centre of the circle is not on the origin. So here is a circle that centre is A, B, and I want to work out the equation of all of the points with coordinates x and y on the circle. Now, key thing about this circle is all of the points on the outside are the same distance away from the centre, and we call that the radius. And I could work out that radius by doing a little bit of Pythagoras. So if I can work out this length here and this length here, then I could square them both, add them together, and that would give me the radius squared. So I can work out that yellow length because it's going to be the difference between the x and the a. So x minus a. I can work out the green length here because it's going to be the difference between the y coordinates, the difference between y and b. So, doing a little bit of Pythagoras here then, we've got x minus a squared plus y minus b squared equals the radius squared. And this is the general equation of a circle that has centre AB and radius R. All circles can be written in this form. Let's have a look at 4 examples using this equation. So first off, really simply, in example 1 here, we're told that the equation, we need to write down the equation of a circle that's got centre 5, 7 and radius 4. So remember, generally, the equation of a circle is x minus a all squared plus y minus b all squared equals the radius squared. So in this case, the a is 5, the b is 7, and the radius is 4. So putting those in the right place then, and the 4 squared is 16. And that's it, that's the equation of that circle. Now, sometimes we might be asked to expand those brackets out and simplify. So if we did that, if we expanded those brackets, we would have x squared minus 10x plus 25. Then with the second bracket, we would have y squared minus 14y plus 49 equals to 16. And then we could put the squared terms at the front, the x squared and the y squared. Then we could put the x term and the y term. And then if we collect up these constants, the 25 plus the 49 is 74. And then we could subtract the 16 from both sides, so it equals 0. The 74 take away 16 is 58. So this is another way of writing that same circle. I don't really like this way of writing the circle. I much prefer this way because it's very easy for me to see what the centre of the circle is going to be and what the radius is going to be. It's much more difficult to do that in the longer form. But we could be given the equation in that longer form, as we will see in a moment. Right, second example. A circle has the equation x minus 3 squared plus y plus 4 squared equals 20. We need to write down the centre and the radius. So the centre of this circle is positive 3, negative 4. The radius squared is 20, which means that the radius would be root 20, or we could simplify that to be 2 root 5. So that's the centre of the circle, and that's the radius of the circle. Part B says to show that the circle passes through the point 5 minus 8. So, if I substitute the x-coordinate of 5 in here, and then substitute the y-coordinate of minus 8 in, and if I get 20, then this point is on the line. If I don't get 20, then it's not. So let's check. So 5 minus 3 is 2 squared. The minus 8 plus 4 squared. So I get 4 plus 16, which is 20. And so I can say yes, therefore 5 minus 8 is on the circle. If I got something that was less than 20, I'd be able to say that it was inside the circle. If I got something that was bigger than 20, it would be outside the circle. Right, third example. In this example, we can see that we've been given the equation in its longer form, and we need to write this in its shorter form so that we can find the radius and the centre. Now, I've already shown some of the working out here. The way that we're going to write this long form in its shorter form is by completing the square twice. So I've collected up the x terms at the front here at the beginning. Then I've collected up the y terms in green here. And then I've just left that 24 by itself there. Then I have completed the square on the x terms. So the perfect square that goes along with x squared minus 10x is x minus 5 squared. And then I've had to subtract the 5 squared. Then I've completed the square on the green terms. So the perfect square that goes with x squared plus 2y. Sorry, y squared plus 2y. Is y plus 1 squared. And then I've subtracted the 1 squared. I've kept the minus 24 there. Then what I've done is I've grouped up the minus 25, the minus 1 and the minus 24 to get minus 50. I'm then going to add that 50 to both sides. And now I can say that the centre of the circle is positive 5, negative 1, and the radius of the circle is going to be, well, I know the radius squared is 50, so the radius is going to be root 50. Or I could simplify that to be 5 root 2. So, just to repeat then, if you get given the equation of a circle in its long form, you're going to split it into its x parts and its y parts, and then complete the square twice to help you to rewrite it so you can read off the centre and the radius. Last example for this video. We're told that the line PQ is the diameter of a circle, and we're given the coordinates of P and Q as 5, 6 and minus 2, 2 respectively. We need to find the equation of the circle. Now, to help me explain this, you can see I've drawn a little sketch there. I've got point Q and P marked on in their roughly correct places. And we know PQ is a diameter, so this is the diameter of the circle. Now, because that's the diameter, I know that the centre of the circle is going to be the midpoint of those 2 points. So if I work out the midpoint of P and Q by adding the two x coordinates and then dividing by 2, then adding the two y coordinates and then dividing by 2, so we get 3 divided by 2 is 1.5. And then 8 divided by 2 is 4. So the midpoint of the PQ and the centre of the circle is the coordinate 1.54. So I've got the beginning part of the equation then. It's going to be x minus 1.5 squared plus y minus 4 squared. But I don't know what the radius is yet. But that's fine because I can work out the radius reasonably simply, because I know that the radius is the distance from the centre of the circle to any point on the circumference. So if I work out the distance between the centre and point P, by working out the difference between the x coordinates, so the x coordinate here is 5, the x coordinate here is 1.5. So the difference between those is 3.5. Then the difference between the y coordinates, here it's 6, here it's 4. So the difference between those is 2. And a little bit of Pythagoras will tell me what the radius is then. So 3.5 squared plus 2 squared, all square rooted, gives me an exact form of root 65 over 2. So that's the radius of the circle. So putting that into my equation, we need the radius squared though. So when I square the root 65, I'll get 65, and when I square the 2, I'll get 4. And this is the equation of that circle.